Here in lesson 14, we're going to be talking about problems about parts of a whole, and we're going to deal with a little bit of simple probability. All right, so here's our first example. 1/3 of the students attended the game. What fraction of the students did not attend the game? And so if we take a whole and we split it up into thirds, we can kind of think about what's happening in a visual sense. So if we split up a whole group, let's say this is the whole group of students represented by a circle, if we split that group up into this group being the third, the group that attended the game, we can see that there are 2/3 left that did not. But we can also think about this in terms of subtraction. If you have one whole group and you know that 1/3 is taken away, or 1/3 is the amount that you're not counting, so we can think about it like subtraction. 1 minus 1/3. 1 minus 1/3 is how we can write this. So watch this. If I'm going to subtract, remember when we have fractions that we're subtracting, we need to make sure that they have common denominators. And the way we can write 1 with a denominator of anything is just to write that number over itself. So 3/3 is the same as 1 minus 1/3 is going to give us just the fraction, which is 2/3, right? Remember, when we have a common denominator between numbers that we're subtracting, we're going to leave that denominator alone and subtract the numerator. So we end up with 2/3. Okay, so Melissenda's, in example 2, we've got Melissenda's science beaker. It's 61% full. What percent of Melissenda's beaker is empty? Well, when we hear something like 61% full, we can kind of think about what it visually looks like. It's going to look like it's more than halfway full, right? But really, the key to this problem is thinking about what does this whole situation mean in terms of fullness. What would we say if this whole thing were filled to the top or filled to the brim? Hopefully, this looks so bad. Hopefully you know that the whole thing filled is 100% filled. But we know that her beaker is only 61% filled. And so the question is, what percentage of it is empty? What percentage of it is empty? So we know that 61% plus the amount that it's empty, let's call it, I don't know, M, has to equal to 100%. Not 180 as I was going to write, but 100%. So basically, this is a subtraction problem. We're going to take 100%, we're going to subtract 61%, and when we take 100 minus 61 with a little bit of borrowing, we're going to see that the answer is 39. So the final answer is 39%. So let's talk a little bit about probability. Probability is the likelihood that a particular event would occur. Usually we say things like, man, that's 100% going to happen, or there's a 50% chance that that's going to happen. We use that language when we talk about rain or we talk about the weather. So one way we like to think about it as mathematicians, please look down here, is from 0 to 1. 0 being definitely not going to happen, impossible, and 1 being definitely going to happen. So we would think about this in terms of 0 to 100% in terms of percentages. So here, when we talk about it from 0 to 1, we can think about this more as fractions or decimals. So we remember there's a relationship between percentages, fractions, and decimals. Well, that definitely plays out when we deal with probability. So when we think about the probability of a specific event, that probability is going to be the number of times the desired outcome, that's this thing, over the total possible number of outcomes. We have a great example here. So this example is saying, suppose we have a bag that contains 4 red marbles and 5 blue marbles. So here's my visual of that. So I've got this bag, 4 red marbles, 5 blue marbles. We want to figure out the probability of picking one marble of a specific color from the bag without looking. So imagine putting your hand in the bag, rummaging around, and you want to figure out what the probability is. So let's think about this. If we're talking about red, which is the favorable outcome here, we have to figure out how many different ways can we get red. That's what the number of favorable outcomes is, and that's 4. And then we have to think about the total number of marbles. Well, altogether, there are 9. So the probability of picking red, which would be either written like this, P of red or P of R, is going to be 4 out of 9. Similarly, we can think about the probability of picking blue. Since there's 5 blue out of all 9, it's 5 out of 9. This is a fun one. What's the probability of picking green? Well, there's no green in that bag of 9 marbles, so it's 0 out of 9, which is 0. So we can say that that's an impossible situation. One of the favorite ways of asking probability questions is thinking about a die, or sometimes we call them a number cube. So you know what a die is? One die, one of a pair of dice. 1, 2, 3, 4, 5, and 6 are the numbers that are on each of the faces. So now we're going to figure out probability here for these things. What's the probability of rolling 4? Well, we know that there are 6 different choices, right? We can get 6 different things could land face up, but we know we only want the one that has a 4, and there's only one way for that to happen. There's only one 4 there. So the probability of 4 is 1 out of 6. Rolling a number greater than 4, well, there's a couple of numbers greater than 4. There's 5 and 6. There's still 6 different choices, but there's only 2 different choices that we have, 5 or 6. We can reduce this to a 1 out of 3. All right, let's take a look at this next one, part C. So we're going to roll the number greater than 6. So we know we only have 6 different choices, but of the 6 different choices, no number is greater than 6. So we have 0 out of 6. This can't happen. And finally, rolling a number less than 7. Well, that happens all the time. Every number on the number cube or in the die is less than 7. So that's 6 out of 6. And that's how we calculate probabilities. So the next very common way that we see represented in mathematics, the idea of probability, is with a spinner. And so a spinner is kind of like anything that you would see in like a game. You spin it and there's a chance that it could land on any of these spaces. And notice that the spaces are equal. And so 1 is as likely to happen as 2 is likely to happen as 3, 4, or 5. So now how many different outcomes are there? Well, we see that there's 5 different outcomes. You can be either in 1, 2, 3, 4, or 5. We'll pretend like the lines aren't really an outcome. We're just using the lines as separation. So there are 5 different outcomes. What is the probability of spinning 3? There's only one way to spin 3 out of the 5 different outcomes. Therefore, the probability is 1 out of 5. What is the probability of not spinning 3? Well, there's several choices for not choosing 3, and that's 4 choices. 1, 2, 4, and 5. Those are the 4 things that are not 3, and so that's 4 out of 5. And that's generally what the text was telling us. There are 5 equally likely outcomes. They go on to share with us that 1/5 is the answer for the one where we had the probability of 3, and the probability of not 3, I like how they wrote that, probability not 3 is 4 out of 5. If you notice that the probability of 3 and the probability of not 3 have to add up to 1, because that would be the entire options. Either it's 3 or not 3. So it has to add up to 1. So here we have a spinner in example 5 where the spaces are not actually equal. We can see that 2 and 3 are either 2 or 3 is equally as likely as 1. You might even be able to look at it and say, hey, I think that 2 is a fraction of this entire spinner situation. And 3 is a fraction and 1 is a fraction. Consider what the fractions are. All right, so let's take a look at this. The spinner at the right is divided into 1/2 and 2/4. What is the probability of the spinner ending on 3? So here we have 3, and we want to know what the probability is. Well, you probably guessed it if you said 1/4, because 1 out of all of it, this piece out of all of it is 1 out of 4. Even though it's not split up into 4 places, we can kind of imagine it split into 4 equal spaces. Make sense? I hope so. With that, you are ready for the practice set, and you're also ready to work on the written practice. Take care.